Hello all. Today I'll show you how to use Cellular Automata model for spatial modeling. I'll use the example of urban growth modeling today to uh, demonstrate how to use the CA model. Let's first go through the basic concepts of CA model. So what we'll be using today is land cover data sets and then other supporting growth parameters such as distance to CBD, which is the central business district, the distance to major roads, the slope of the region, and population density map calculated at the ward level. So as you all know, the raster dataset is collection of cells, pixels, with values, some DN values that represent the color it belongs to, the class that it belongs to. So in a cellular automata model, what happens? A kernel of some size defined by us goes through the array of values, the DN values of raster. So the kernel flows through the raster, each and every cell, and decides the future state of that cell based on the neighboring cells values. So this is a raster showing distance to road. So how the algorithm works? So this is step 1, in which the kernel is at the very left cell of the raster. It can't be extreme left because the extreme left, upper left pixel does not have neighbors on all sides. That's why it has to skip the first row and the first column depending upon the size of the kernel again. And then uh, here 4 is the test pixel. So in the road distance layer, in the CVD distance layer, in the population density layer, and the slope density layer, it checks whether the value of that layer is greater than the threshold defined by the user or not. If the threshold is greater, it replaces the value to 1, which is built up, which means the model says that the built up growth will take place. And once that is done, it moves ahead with step 2, does the same thing for the second pixel with value 2 in the main raster, and checks the threshold in all the other raster data sets, then goes for the next pixel and the next pixel, and so on. So this is how the kernel moves and decides what to do. The different 4 parameters that I've showed here as a small matrix so that they are clearly visible. All of them have the same rows and column numbers. Just to demonstrate it, I have made it larger and to avoid confusion. So that's how the cellular automata model works, going to the test pixel one by one and checking the transition rules defined by the user. If the transition rules are satisfied, the minimum threshold requirement is met, then the transition of that cell takes place. So this is the present study in which I used the 1989 land cover map, predicted 1994, and then did accuracy assessment. So it's a hit and trial method. You need to predict once, and then you need to go back and check what's the accuracy of your model, and then based on that, you manipulate the thresholds that you have defined for your model, and then you keep on changing it until you meet the desired accuracy. And then you use in similar way, like using 1989 to predict 1994, using 1994 actual land cover map to predict for 1999, to use the 1999 actual land cover to predict 2004, and so on. And once you reach 2014, you can take any years. I have taken 5 years. That's not necessary. So you can directly take 10 years, 15 years based on your requirement. So similarly, once the model is trained and you get some rough idea of the thresholds, you can use the 2014 land cover map to predict for future. Okay, so in the next video, we'll be doing hands-on practice on using Cellular Automata model for urban growth modeling. Thanks for watching this.